Good morning, guys. Mr. Parisi here, and today we're going to be going over Unit 4, Lesson 7 homework. Now, just as a heads up, if you did not complete this homework, or if you left some questions blank, you can follow along with this video and complete the work on a separate sheet of paper and resubmit it on that Google Classroom post, okay? And that'll get you most of the credit. But remember, you have to complete it on a separate sheet of paper and you have to post it to Google Classroom. Okay, otherwise we can't give you credit for it. So let's get into it. Number 1 says a water tank is being filled by pumps at a constant rate. The volume of the water in tank V in gallons is given by the equation V of t equals 65t plus 280, where t is the time in minutes the pump has been on. So for A, at what rate in gallons per minute is the water being pumped into the tank? So for these questions, we're talking about y equals mx plus b. We're talking about a linear relationship, okay? So what we need to know is that my m is my average rate of change, and my b is my initial value. That's my starting point, okay? Two key ideas that are going to keep resurfacing as we go through these linear problems. So at what rate? Your rate is just your average rate of change. So what's in my m spot? In this case, it would just be that 65. So my rate would be 65, and we're using gallons per minute here. That's all number 1's asking. For B, it says how many gallons of water were in the tank when the pump was turned on. So when it was turned on, when it started, your initial value. Again, my initial value is just that B. Okay, my B value is just 280. So there were 280 gallons when the pump was turned on. Just getting you to identify these two. Now, what is the volume of the tank after 2 hours of the pumps running? In this case, they gave me 2 hours, which is my time. That's my t. So wherever I see a t, I'm going to replace it with 2 hours. But this equation, as we set up here, is in terms of minutes. So 2 hours, you have to realize, 2 hours is just 120 minutes. So what I'm actually going to plug in is the 120. So V of 120 equals 65 times that 120 plus 280. And then when I plug that into my calculator, I end up getting 8,080. And this is my volume, so that would be in gallons. Okay, and lastly, part D. The pump will turn off when the volume in the tank hits 10,000 gallons to the nearest minute. After how long does this happen? So in this case, they didn't give me time. That's what I'm looking for. They gave me my gallons or my volume. So they gave me my volume, but I plug in on my right side, my V of t. And that's going to equal 65t plus 280. Now I can solve this just like I would any other equation. Subtract that 280 minus that 280. I'm going to be left with 65t equals 9,720. Divide by 65, divide by 65, and I have my t equaling 149.53, yada, yada, yada. When I round this up, because it does say to the nearest minute, this is just going to be 150 minutes. And that's question 1. Question 2 says a solar lease customer built up an excess of 6,500 kilowatt hours during the summer using his solar panels. When he turned his electric heat on, the excess began to be used up at a rate of 50 kilowatt hours per day. If E represents the excess left and D represents the number of days since the heat has been turned on, write an equation in terms of for E in terms of D. So we want our equation for E. So that means we're starting with E, my electricity, in terms of D. So my D is going to end up being on the other side. It's important to know this is linear, so we're still modeling it after y equals mx plus b. So what is my rate of change? So my rate of change in this case would be right here. It's being used up at a rate of 50 kilowatt hours. So if it's being used up, that would be a negative 50. I'm losing 50. Okay, that's kilowatt hours per day. Negative 50D. And then what did I start with? What was my initial value? Is going to be, boom. They built up that excess of 6,500. So they started at 6,500 and they're losing 50 kilowatt hours per day. For part B, how much of the excess will be left after 1 month? So use a month length of 30 days, because again, our equations in terms of days. So they're giving us the time. They're telling me my D is 30. So E of 30 equals negative 50 times that 30 plus 6,500. You could plug this all into your calculator, and it should come out to 5,000 kilowatt hours, or kilowatt. Yeah. So E of 30 equals 5,000 kilowatts. And last but not least, if the heat will need to be turned on for 5 months, will the excess be enough to last through this time period? Justify your answer. So in this case, they're giving you 5 months. Okay, 5 months is how many days? If we're using 30 days in a month, 5 times that 30 is going to get me 150 days that I'm dealing with. So this is going to be my T. All right, so got my equation, E. I'm going to plug in for T. Negative 50 times 150 plus 6,500. When I solve that, I should get a negative number. What this number means, negative number for kilowatts, what this number actually means is that you don't have enough. You have a shortage, okay? I have a shortage of 1,000 kilowatt hours. So that's reading into the real life situation of it. What does that negative number mean here? It means there's a shortage. Question number 3 says, as Evan is driving her car, she notices that after 1 hour, her gas tank has 7.25 gallons left, and after 4 hours of driving, it has 3.5 gallons left in the tank. Represent the information as 2 coordinate pairs in the form of H, G, where H is the number of hours driven and G is the gallons of gas left. So we really just need 2 pairs here. Okay, my first one would just be after 1 hour, there are 7.25 gallons. My second one is going to be that after 4 hours, there are 3.5 gallons. So 4 hours and 3.5 gallons. That's it. That's all part A is asking for. Part B says, find the slope between the 2 points. So we have to remember that my slope equation is y2 minus y1 over x2 minus x1. We look back here, that's my x1, y1, my x2, y2. So this one is really just 3.5 minus 7.5 over 4 minus 1. When I solve that out, that's going to come to negative 3.75 up top and then 3 on the bottom. So when I plug that into my calculator, that'll just come out to a negative 1.25 gallons per hour. And what that means is she's using about 1.25 gallons per hour. So as she's driving, that's how much is being used up every hour. Okay, assuming the relationship between H and linear, find an equation for G in terms of H. An equation for G. Okay, again, linear, y equals mx plus b. y equals mx plus b. So my y, it says it's in terms, it's 4g. So it's going to be g equals, now I need to know my change. My change in this case is going to be what we just found, my slope there, 1.25 h. And then what is my starting value? For this question, my starting value is not given to me. So I have to look at what I have at 1 hour. At 1 hour up here, I'm at 7.25 gallons. So if I know I use 1.25 gallons every hour, in that first hour, that's what I had to use. So working backwards, I could add that 7.25, that's after 1 hour, plus 1.25 to get me back to 8.5 gallons. That would have been my starting value right there. Okay, so plus 8.5. And I have my equation now. G equals negative 1.25 H plus 8.5. And lastly, D. According to this equation, after how many hours of driving would Evan run out of gas? So if I ran out of gas, my G would have to be 0. So it's going to be 0 equals negative 1.25 H plus 8.5. Let's solve this equation. Minus 8.5 minus 8.5. And I've got negative 8.5 equals negative 1.25 H. Have to divide by negative 1.25. Work my way down here a little bit. Divide by negative 1.25. And that comes to 6.8 hours. So after 6.8 hours, that's when I would run out of gas. Number 4 says the population of Champaign, Illinois is given for 3 years in the table below, using 1970 as t equals 0. So basically, they don't want you to think of this as 1970. This is my starting point. This is my 0 right here. Okay, that would end up making this 10, and that would end up making 2012. Well, what would that be? 30 years that to 2000, 12 more years. That would be 42, really. Okay, so when they're telling me, hey, this is my starting point, you don't even need to worry about these years, really. Okay, it's just saying, hey, this is where I started. This is 10 years later. This is 42 years later. So using t as 0, create a linear model from the first 2 data points in this table to predict the population as a function of the number of years. So we need to make a linear model, so meaning y equals mx plus b. So that would mean we'd have to find m and we'd have to find b. So the first thing, the easiest thing that we can do is find my average rate of change, y2 minus y1 over x2 minus x1. I have my y2 here. Change this. This is my y1, my x1, my x2, and my y2. So let's go ahead and plug these in. Got my 1, 6, 8, 392 minus 1, 6, 3, 4, 8, 8 over my 10 minus 0. So my slope, in this case, once I calculate all that out, is going to come out to 4904 over 10, which is really just equal to 490.4. And that is people per year. That's how my population is changing. People per year. Increasing by 490.4 people per year. So that's just part of it. We have the population, but now I need to, or the average rate of change, and now I need to write my equation. So y equals mx plus b. My population is just going to be equal to my change right here. That m is your change, 490.4 every year. And then what did I start at? What did my population begin at? In this case, it began at 163, 488. That was my starting value for this problem. So this is going to be the equation that we use, that we work off of. So for B, it says, if this model is used to predict the population of Champaign in the year 2012, will the model overestimate or underestimate the actual population? So it says, okay, let's use it for 2012. Remember, 2012 is really just the year 42. So my population is going to equal 490.4 times that 42 for that 2012 in that 42nd year plus 163,488. And as I go about figuring this out, it comes to a population of 184,084.8 people. So 184,084.8 people. Now, is that more or less than what it actually is? Let's take a look. My actual number is this. It's estimated here. So you would say this estimate is definitely an underestimate. Okay, so this is a underestimate for the population. And the reason being for that would be population doesn't necessarily have a constant rate of change. Okay, so even though we calculated that average rate of change here for these first two, population doesn't necessarily have to stick to this, right? That's not something that has a constant rate of change. Underestimate for the population because the population doesn't have a constant rate of change. And there you have it. More with linear modeling. Now remember, take your time, fill this out on a separate sheet of paper, take a picture and submit it to the post, the original post for Unit 4, Lesson 6 on Google Classroom. It's the only way we can get you credit. Thank you so much. Have a great day, and I will see you in the next one.